Hello, my dear student. Welcome to Exam Prep Tool. If you are preparing for GATE CSE or GATE DA, this is the correct place. 300 questions, 300 quality questions I am going to explain here. Mostly in GATE examinations, questions will come from these 300 questions only. Most of my students every year used to say this only to me. Sir, questions came from your notes. So I'm strongly saying to you, don't miss one question also out of these 300. It will really helpful to you in the examination. You will get a lot of advantage. First of all, myself, I am Subbarao Lingam Gunta. My students used to call me Reddy sir. I have 14 years of teaching experience. I guided more than 25 lakh students. Right? And one more thing I want to say to you, I am from IIT Bombay, right? In computer science department. I am the GATE top ranker. All my team members are IITians. 300 quality questions we made. Don't miss one also. Definitely most of the things will come in the GATE examination. And while seeing this lecture at anywhere, if you find out any doubt, this is our WhatsApp number, right? Message us. This is our WhatsApp number. Please message us, right? Your doubt will be resolved by our team members. Hope this class will be really useful to you. Go ahead. 31. I think 30 problems we done. It is the question number 31. Yeah, check once. What is the answer of this problem? Diksha, good evening. Good evening, Diksha. So please go ahead. So let S be a set of consisting of 10 elements. Let S be a set consisting of 10 elements. The number of tuples of the form A, comma B such that A and B are subsets of S and A is subset of B. Yeah, can you go ahead? Today we have to complete many problems because in one of the two classes, right, one or two classes we wasted 1 or 2 hours. 1 hour or 1.5 hour we wasted. So we have to complete many problems now. Let S be a set consisting of 10 elements. The number of tuples of the form A, comma B such that A and B are subsets of S and A is subset of B is. So this may be the case. So if at all S contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If S contain these many elements, from S you have to select two subsets. One subset A, one more subset B. You have to select two subsets A and B. From the S, so select two subsets A and B. The number of tuples means how many ways you can select like this. From S, so select two subsets A and B. How many ways you can select like this? But the condition is A and B are subsets of S, so that is the one condition. And one more thing is A is subset of B. A is subset of B means comparing A and B, B bigger are equal, but A is subset of B. So what is the answer? Somebody saying, can I ask? What you want to ask? Go ahead. Yeah, so what is the answer for this? So remember from S whatever elements you take, from S whatever elements should be whatever elements you will take, right? So right, remember A is subset of B and A and B are both are subsets of S. A and B are both are subsets of S, and within the A and B itself some condition there. A is subset of B. Yeah, now see this. So one possibility is you take any element of S. you take any element of S, one possibility is, let us assume I will take one element X from S. So one possibility is X not belongs to A, X not belongs to B. That is the one possibility. Because A and B are subsets, I think there is no problem. I cannot say that every element, right? And one more thing is X belongs to S. X belongs to S, right? Take one element. There may be chance that X may not be belongs to A, may not be belongs to B. Right? So that is the one choice. One more thing is, if you take any element of S, right, that element should be there in both. That is also okay. In both of them, that element is there. X belongs to S, that X will be belongs to both. That X is belongs to both. That is also. If it is belongs to both, I think A and B are subsets of S satisfied, and A is subset of B also satisfied. And A is subset of B also satisfied. B may be subset of A, may not be. There is no condition. Yeah, that is also okay. And one more thing is, one more possibility if you observe, the element X what you are taking, it is not belongs to A, but it is belongs to B. That is also okay. And X belongs to S. Right? So every element whatever you take, right, one of the things should happen. For all X belongs to S, either this should happen. For all X belongs to S, so one of the possibilities should be happen. For all X belongs to S, so one of the possibilities should be happen. That X belongs to both. X not belongs to both. X not belongs to A but belongs to B. Sir, how it is possible, sir? A is subset of B. It is possible. A is subset of B. It is possible. So for every element 3 choices possible, because of you have 10 elements. So 3 power 10. For every element 3 choices possible. For 10 elements 3 power 10. Whatever it is. 3 power 10 value I don't know. You calculate properly. Fine. I don't know exactly a power, right? 3 power 10. You calculate properly. Using you can use calculator, so you can use it. You calculate properly. I have one doubt in algo. Can I ask here? How can you ask? What is the class going on? How can you ask? You could have asked me. In the, right? You can WhatsApp me. You can post in the group. Post in the group. So can I move to next problem? Diksha, can I move to next problem? Diksha, your answer may be correct. Same answer may be. So similar kind of problem will come, you cannot leave. In exam, similar kind of problem will come, you cannot leave. Please take care. The purpose of studying all is, similar thing will come in the exam, please handle. In exam, you are nothing to do new. In exam, there is no time to do new things. Whatever happened in the classroom, similar things will come. Please handle. In exam, you are nothing to do new. I think this problem is everyone is fine. Can you go to problem number 32? So what is the answer? Problem number 32. Let S be a set of consisting of 10 elements. The number of tuples of the form A, B, C such that A, B and C are subsets of S and A is subset of B, which is the subset of C is. Yeah, can you try? What is the answer? Same problem, little variation I done. 10 elements are there. S contain 10 elements. S contain 10 elements. S contain 10 elements. From the 10 elements, you have to select 3 subsets A, B, C. A, B, C. Condition is A subset of B, subset of C. All three are subsets of S first. But the one more condition is A subset of B, which is a subset of C, and so on. Now let's try I think similar problem. Let's see similar problem. For all x belongs to S, one of the possibilities should happen. See the one possibility. X not belongs to A, X not belongs to B, X not belongs to C. That is the one case. One more case. X belongs to A, X belongs to B, X belongs to C. One more case. So one more case is, let's see. One more case is X not belongs to A, X not belongs to A, X not belongs to B, X belongs to C. That is the one case. One more case is X not belongs to A, X belongs to B, X belongs to C. Like this. X not belongs to all three. X belongs to, right, all three. X belongs to only C. X belongs to only B and C. I think if you observe clearly, I think every element having 4 choices, 4 power 10. Every element having 4 choices, 4 power 10. Similar problem will come, please handle properly. Similar problem will come, please handle properly. In exam, you cannot do anything new. In exam, you cannot do anything new. And if you don't study, you will be victim. It doesn't matter how much talented you are. If you don't practice, you become victim. If you don't study one topic, you are going to be victim. Right? So please take care. Here, no one is great here. If you do more practice, you are the hero. If you do more practice, you are the hero. If you don't do practice, if you come, right, you are the victim. So if you okay with the problem number 32. Diksha, if you okay, I can go to the next problem. Can we move to next 33? 32 is 4 power 10. 32 is 4 power 10. 33. Can you go to 33? Yeah, try what is the 33 answer. Yeah, 33. Let n be the set of natural numbers. Consider the following sets. Let n be the set of natural numbers. Consider the following sets. Let n be the set of natural numbers. Consider the following sets. P. Set of rational numbers. N is the set of natural numbers. Okay. Consider the following sets. Set of rational numbers. Right, is given a positive and negative both rational numbers. P is a set of rational numbers. Q, set of functions from 0, 1 to n. R, set of functions from n to 0, 1. Set of finite subsets of n. Set of finite subsets of n. Yeah, check what is the answer for this. Good evening, Jay. Good evening. Check what is the answer for this. So someone is saying D. Jyoti is saying D. Yeah. Let me say one small line. If anyone don't know, please take care. If anyone don't know, please take care. Can you help me now? P. What is the P? What is the P? Set of rational numbers. P is set of rational numbers. Everyone knows set of rational number is countably infinite. Set of rational numbers are real numbers are not countably infinite, but set of rational numbers are countably infinite. Countably infinite means countable. Countably infinite means countable. Set of rational numbers are countable. Set of natural numbers are countable. Countably infinite. So I will write that also. I will write, see, set of natural numbers. Set of natural numbers countably infinite means countable. Next one, set of integers. Set of integers. It is also CI means countable. Set of natural numbers over, integers over. Next one, rational numbers. Rational numbers countably infinite, countable. Next one, set of real numbers. Real numbers. What is the answer? Countably infinite. No, it's uncountable. It is uncountable. Please careful. Set of complex numbers. Complex numbers uncountable. If anyone don't know, please can you remember? If anyone don't know, please remember this. If anyone don't know, please remember this. Yeah, good evening. Good evening. Set of natural numbers. Countably infinite means countable. Set of integers. Countably infinite means countable. Set of rational numbers. Countably infinite means countable. Set of real numbers. Uncountable. Set of complex numbers. Uncountable. Yeah, next, one more thing. If anyone don't know, please take care of this. If anyone don't know, please take care. See the next one. See the next one now. Until now it's fine, right? See, everyone listen. If something is countably infinite, right, power set of this is uncountable. If anything is countably infinite, power set of that is going to be uncountable. Right? That is called Cantor's theorem. There is one theorem called Cantor's theorem. Right? So if anything is countably infinite, its power set is uncountable. If anything is countably infinite, its power set is uncountable. If anything is right, countably infinite, its power set is uncountable. It is already uncountable. Its power set is definitely uncountable. Right? Please, if anyone don't know, please remember. Power set of countably infinite is uncountable. Power set of countably infinite. Power set of countably infinite is uncountable. Power set of countably finite is countable only. Power set of countably finite is going to be countable only. But a power set of countably infinite is uncountable. Cantor's theorem. One theorem is there, Cantor's theorem. Okay, I think that is fine. That is fine, right? That's fine now, right? Now can you come here now? If you really okay, P. What is the P? Set of rational numbers. Countably infinite means countable. Set of functions. See this one. Set of functions. from 0, 1 to n, how much? How many functions can anyone say? 0, 1 to n, how many? For the first one, n choices. For the second one, for the first one, n choices. Second one, n choices. I think n into n, n square. N into n, n square. First one, out of n people, anyone you can map. Second one, out of n people, anyone can map. N square. N square is countably infinite because of natural numbers. N square, right? Set of natural numbers only. Remember, countably infinite. Two countably infinite you add, countably infinite only. Two countable infinite you multiply, countably infinite only. Two countable infinite, right? You do addition, you do multiplication, you do division, right? Addition, right? Between two countable infinite, if you do some operation, it will be countably infinite only, means countable only. But power set of countably infinite is uncountable, right? Yeah, so it is every day, and every day I decided to keep morning 6 o'clock. Can I keep morning 6 o'clock, 6 a.m.? Can I keep morning 6 o'clock, 6 a.m.? Product of countably infinite is countably infinite. Tomorrow onwards class is 6 a.m. Tomorrow onwards class is 6 a.m. Yeah, fine. So I think second one is countable infinite. See the third one. Set of functions from n to 0, 1. Set of functions from n to 0, 1. Can you see this one? Set of functions from n to 0, 1. See, n to 0, 1. First person, 2 choices. Second person, 2 choices. Third person, 2 choices. Fourth person, 2 choices, and so on. Last person, 2 choices. It will become 2 power n. Everyone know, n is countably infinite. 2 power countably infinite is uncountable. Is uncountable. N is countably infinite. 2 power n uncountable. 2 power n uncountable. So remember, R is uncountable. R is uncountable. Set of finite subsets of n. Set of finite subsets of finite is saying finite. See this one. Interesting answer. Set of subsets of n is 2 power n, which is going to be uncountable. But he is saying finite subsets. Finite subsets are countable only. Finite subsets are countable only. So yes, also true. Set of finite subset. If the question is set of subsets of n uncountable. Set of finite subsets, that is the reason it became countable. So answer is PQS is countable, R is uncountable. It is a nice problem. Please take care. For 12 subjects of GATE examination, every subject is approximately 200 questions to 300 questions. 300 quality questions were designed. 12 subjects, every subject 200 to 300 quality questions were designed. Approximately 2400 questions to 3600 questions. These many quality questions were designed with video solutions. Mostly in GATE examination, all questions will come from these only. 12 subjects, every subject 200 to 300 questions. Our team is all IIT experts. Myself, as I mentioned to you, 14 years. Most of my students are they're in IIT. Most of my students are there in MNCs, big MNCs. Most of my students are top 100 rankers, top 10 rankers, top 50 rankers. If you solve all these questions, I'm very sure your rank will improve by at least 10 times. Through experience, I'm saying mostly questions will come from these questions only. Don't miss at any cost. So for if you want to subscribe for this course name is called as rank improvement course for CS, rank improvement course for DA, right? For admissions, you can WhatsApp me to this particular number, or you can directly go to exampreptool.com. You can subscribe from there also. It is really useful to you. Don't miss at any cost. This is right. Utilize the last 2 months quality time in the quality way. Right? I hope right you will get a lot of benefit from this. Right? All the best. Question number 34. Yeah, try what is the answer of this. Consider the following two statements. Consider the following two statements on cardinality of A. He defined the A first. See this one. He defined A first. He defined A. He is asking cardinality of A. Diksha Prasad, it's like Devi Prasad. Preeti, if I give one kick on the nose, Preeti, if I give one kick on the nose, your nose will go inside your nose. A serious problem is going on. She is saying, Diksha saying, right? Sorry, Preeti saying Diksha Prasad is like Devi Prasad. One kick if I give on your nose will go inside nose. I thought you were seriously discussing. The problem. You are doing research on the people name. Nose will go inside nose. Yeah, can you solve this? Let u is equal to 1, 2 and so on n, and A is equal to x comma x, x belongs to x, and x subset are equal to u. Consider the following two statements on A. A contain all elements in the form of right, A comma, so this one, x comma capital X. A contain all elements in the form of small x comma capital X. But from where this small x is coming? Small x belongs to capital X. Capital X is a subset of U. U is a universal set. That is the condition. So A contain these kind of people. A contain small x comma capital X kind of elements, where small x is belong to capital X. Capital X is a subset of U. From the U, take one subset that is called X. In the X, take one element that is called small x. So A will contain all the people of this form. A will contain all the people of this form. Right? So I will try one small example. I will try. Universal set U is equal to 1, 2, 3, 4, 5, 6. Universal set U is equal to 1, 2, 3 and so on 6. Next one. X is equal to I'm taking few people. 2, 3, 4. X is equal to 2, 3, 4. Now what is the cardinality of A? Now what is the cardinality of A? What is the cardinality of A? Yeah, first can you try one example first? Afterwards we will see the answer and all. What is the cardinality of A? Right? Cardinality of A, if you observe, see this one. Cardinality of A, if you observe cardinality of A, can you see this one? This may be the one case. First to take 2, right? First to take 2, 2, 3, 4 is one story. Remember, these 2 should be there in both. These 2 should be there in both. Right? These 2, I think one person I took already this. One person I already took like this one. I think one more. X can be, right? 3, 4. Let's see. So this is going to be 3, 3, 4. And one more thing is, if you observe clearly problem, right? X is subset of U and X belongs to A. Remember, X should have it. Other people I don't know, X should have X, but it cannot be like this one. 2, 3, 4 you cannot write. This is not possible. X can be this, X can be this, X can be this also, only 4. See this? 4, only 4. Yeah, try to understand. So if you okay with this, so what is the cardinality of A? See this one. Cardinality of A is, everyone listen. Cardinality of A is very well. From the universal set, you have to take one set X, where one element of X you have to keep in the first place. Now listen everyone. Everyone listen. If you take 1 as fixed, if you take first place 1 as fixed, now in this one, 1 should be there. Other people having choice, but 1 should be there. Other people having choice. Other people how many? N minus 1. N minus 1, how many subsets possible? 2 power n minus 1. So these people, right? These people can be changed to 2 power n minus 1 ways. So here 2 power n minus 1 ways are there. Means which is nothing but 2 power 9. In the similar way, if you take 2, compulsory here 2 should be there. Remaining people you can adjust to 2 power. Actually 10 people, let them there is a 6. It is going to be 2 power 5. 6 minus 1. It is also 2 power 5. Right? Next one. If I take 3 compulsory, here again 2 power 5. So I think if you observe clearly, what is the answer? N people are there, so n into. If at all here 6 people are there, 6 into 2 power 5. If at all n people are there, n into 2 power n minus 1. Please check if anyone is not getting. Other people, so n people, number of subsets possible 2 power n. N minus 1 people, number of subsets possible 2 power n minus 1. Right? So first person has 1, 2 power n minus 1. First person has 2, 2 power n minus 1. First person has 3, 2 power n minus 1. And so on. 6 times 2 power n minus 1. So n times 2 power n minus 1. Are you okay with this? See, everything is difficult when you do first time. Do before exam as many problems as possible. Without doing anything, if you go to exam, everything difficult. See, sometimes without practice I will come to class. That day I will trouble. Sometimes long time before. I may be done long time before. Sometimes I will come without practice. I will also trouble. It don't spare anyone. It will trouble anyone. If you don't respect, it will trouble you. Please do enough practice before exam. Please do enough practice before exam. So for us, answer is going to be 6 into 2 power 5. 2 power 5 is 32. 6 into 32. So 6 2 is 12. 6 3 is 18. 19. 192. So 192. Answer is, if I take the U as U contains 6 people, 192 is the answer. 192 is the answer. But what about this one? What about this one? Let me check. Right, sigma, right, k is equal to, right, 1 to n value 6, substitute here, you will get the answer. If at all k value, k is equal to 1 to 6, k value 1, what is the answer? 1 into 6c1, k value 2 into 6c2, k value 3 into 6c3, k value 4 into 6c4, k value 5 into 6c5, k value 6 into 6c6. Yeah, calculate what is this value. Calculate this value, how much? 6c1 is, I think, 6. 6c2. 6c3. What is 6c2? 6 into 5 by 2, 15. Verify. 6c2. 6 into 5 by 1 into 2, 3, 15. 15 into 6, 90. 6c3. Verify if I done anything wrong. 6 into 5 into 4 by 1 into 2 into 3. 6 cancel. 5 4s 20. 23s 60. Next one, 6c4. 6 into 5 into 4 into 3 by 1 into 2 into 3 into 4. Do whatever way you like, no objection. 4 cancel. 5 3s 30. 6c4. 6c4 means 6c2. 6c2 is going to be 15. Is it 60? How much? If I done any calculation wrong, please verify. First one is 6 only. Second one, I think 2 30s. Sorry, 2 15s. 30, right? 6c2. I think 15. 15 2s 30. 6c3. 23 is 60. So next one, 4 into 15, 60. 6c5 means 6c1, 30. So 6. 8, I think 192. This is also 192. Take small example and verify. If you think that it is taking more time, take small example and check. If you think that it is taking more time, take small example. Most of the time in the exam, you cannot try for proofs. Take small example and check. Because of n value 6 I am taken, it is taken a lot of time. Take n value 3 maybe. You will complete the work immediately. So answer is both 1 and 2. You can give proof also, it may take more time. Right? Please take care. In exam, nothing to do. In exam, there is no time, right? 65 questions, 180 minutes. You have to make it fast. So remember this one equal to this one. From now onwards, you remember. These two are same. N into 2 power n minus 1 is equal to sigma k is equal to 1 to n. So k into n c k. These two are equal. Please take care. Please take care. From now onwards, you remember this formula. N into 2 power n minus 1 is equal to sigma k is equal to 1 to n k into n c k. These two are same. When you get the next time, take care. Yeah. Can you go to the next problem? So question number 34 over 35. What is the 35 answer? Verify 35. Verify 35. For a set A, the power set of A is denoted by 2 power A. For a set A, the power set of A denoted by 2 power A. If A is equal to 5, 6, 7. A is equal to, if anyone is unable to see, A is equal to 5 and 6 and 7. A is equal to 5, 6 having bracket, 7 having bracket. Right? For a set A, power set of A denoted by 2 power A, that is okay. A is given like this. Then he is asking which one is right, which one is wrong. Which one is right, which one is wrong, he is saying. Right? So remember, power set of A is 2 power A. So everyone know if it is a power set of A contain 3 people. A contain 3 people, power set of A, 2 power A contain 8 people. 2 power A, so 2 power 3 contain 8 people. If you want, you can list out all the 8 people. I am listing out, only for namesake I am listing out. See the first one, don't take anything, is the first one. Second one, take one person. Take one person, see the one person, first one, 5. Take one person. Second one is not 6, bracket 6. Again 6. Third one is bracket 7. See, all are subsets. When you say subset, bracket required. If it is already having bracket, keep one more bracket. When you say subsets, when you say you are writing subsets, you have to keep bracket. Already bracket there, keep once again. So I think this is going to be, out of 3 people selecting no one, 3C0. It is 3C1. It is the 3C1. Now go to the 3C2. 2 people. 5 and 6. Next one, 5 and 7. Next one, 6 and 7. So I think out of 3 people selecting 2, 3C2. This is a 3C2 area. Now 3C3, 5, 6, 7. It is a 3C3. Now you can go and you can check one by one. What is the answer? Pi is, listen, pi is the element of 2 power A. Yes. But remember, pi is the subset of every set. This is also true. It is always true. Pi is subset of every set. Pi is not only subset of power set. Pi is subset of every set. Remember everyone, second point is true every time. Pi is subset of every set. First one is pi is element of 2 power A. True. See, in the 2 power A, pi is one element. But pi is subset of every. This is always true. Irrespective of set. Whichever set it is always true. But remember, pi belongs to A. Wrong. But pi belongs to 2 power A, right? Because it is there. because it is there. Pi belong to 2 power a, pi belong to a is wrong. A don't have pi. Pi, right? Pi belong to 2 power a. Pi is subset of every set. Pi is subset of a also. Pi is subset of 2 power a also. Pi is subset of b also. Pi is subset of every set. So 1 true, 2 also true. 1 sometimes true. So in our problem 1 is true. Right? So 1 may not be true in other cases. But 1 is true here. But 2 is always true. Go to the 3. 3, I think some small trick there. Listen. 3 is small trick there. Can you help? When you say belong to element. When you say, when you are using belong to element. Can you help? 5, 6 brackets, again bracket. Is it one element? Is it one element of 2 power a? 5 comma 6 bracket. Is it one element of 2 power a? Exactly. It is a one element of 2 power a. True. It is a one element of 2 power a. But remember, is it subset of 2 power a? When you say subset, you have to keep one more bracket. When you say subset, you have to keep one more bracket. Now, if anyone having small doubt, can you see this one? If anyone having small doubt, can you see this one? 1, 2, 3. Listen. 1, 2, 3. Everyone listen. 1, 2, 3. 1, 2, 3. Be careful. 1, 2, 3. 2 belong to A. True. Right? But remember, 2 belong to A. 2 belong to A. But you cannot say 2 subset of A. You cannot say this. One element taking, you can use belong to. You cannot use subset. If you want to say subset, you can say like this. You can say like this one. Right? 2 is subset of A. That is true. When you say subset, bracket required. Here no bracket. That is the reason wrong. 2 belong to A. 2 is not subset of A. If you want to say subset, keep bracket. Keep bracket. This is checking the basics. This is the checking basics. If you are unable to give answer for this, you don't know set theory. If you are unable to give answer, you don't know set theory. When you say subset, bracket required. When you say subset, bracket required. When you say element, no bracket required. So finally, 1, 2, 3 correct. 1, 2, 3 correct. So C. Right? 35 C is the answer. 35 C is the answer. Please careful. 35 C is the answer. Careful. This is the very, very important line. Can you see this example? If anyone is not getting, take care this example. You are almost okay. Take care. If A is equal to 1, 2, 3, 2 belong to A, but 2 is not subset of A. If you want to say subset, keep one bracket. 2 is subset of A. Right? Fine. 35 is over. Aniket. Yeah, thank you, Aniket. Thank you so much. Thank you so much. Thank you. Thank you very much. Now go to the next problem. Go to the 36. Go to the 36. A relation R is defined on the set of integers as x or y if f of x plus y is even. So it is not the if f of, if and only if. This is if and only if. If and only if. So you want to say that x and x and y are related if and only if x plus y is even. X and y is related if x plus y is even. X and y is related if x plus y is even. Hi Aman. A relation R is defined on the sets of integers as x or y if x plus y is even. Yeah, now you start one by one. So remember, so R is defined on the sets of integers. R is defined on the sets of integers. R is defined on the sets of integers. So remember, even odd concept means, right, there is no negative numbers, only positive numbers. A relation R is defined on the set of integers as x or y if and only if x plus y is even. Negative number, there is no meaning of even and odd. अरे युग, अरे ping me first of all. Ping me. What problem you have? The people who don't have two legs also they are leaving. The people who don't have eyes also they are leaving. The people who don't have hands also they are leaving. You have everything. Why you don't want to live? God is given 100 years life. Why you want to live this? I seen so many YouTube videos. Legs not there, hands not there. Still he is fighting for life. Eyes not there, ears not there. Still they are fighting for life. They are enjoying the life. What less God is given to you? What less God is given to you? Everything fine. You are typing means you are everything fine. As a human you have problem. I also having problem. Who don't have problems? Who don't have problem, yeah? Maybe you have some problem. Everyone having some problem. For small thing, okay, don't leave. Small things also don't leave, yeah. You want life without any problem. Everything you want in plate. Whatever you want should come in the plate. Then you will eat happily. Everyone having problem. Please do whatever possible from your side. Do whatever possible from your side. Do. You kept your name as Yug. Yug means you know. Yeah, what is the solution for this? X relation y if and only if x plus y is even. Which one of the following statement is true? You please send the message to me. Right? You please send the message to me. Right. So what is the answer for this? Which of the following statements are true? Can you help me now? Egypt, right? He is saying that some equivalence relation and all. Let me try is it equivalence relation or not? See this one. Two people are related if their sum is even. Two people are related if their sum is even. Can you help me now? If I take 5 is related to 5 or not? Their sum is 10, which is even. Yes. Next one. 7 related to 7 or not? Their sum is 14. 2 into 7. Even. It is a 2 into 5 even. So what I want to say is it is a reflexive. It is a reflexive. It is reflexive. So same number associated. Same number associated. It is reflexive. And one more thing is, see this one. One more thing is 2 related to 4. 2 related to 4 because it is a even. 4 also related to 2. So it is symmetric. It is symmetric. 2 related to 4 because even, 4 related to 2 also. It is a symmetric. It is a symmetric. Now see the trans 2. Now see the trans 2. 2 related to 4. 4 related to 6. This is 2 plus 4 is 6. 4 plus 6 is 10. Both are even. Then these two are also 8, which is even. 2 related to 4. 4 related to 8. Then 2 related to 8 also. So this is even. This is even. This is also even. So trans 2 also satisfied. So everyone know. If anyone don't know, please remember it is a equivalence relation. It is a equivalence relation. It is a equivalence relations, everyone know, right? Equivalence relation in the sense reflexive, symmetric, trans 2. Right? Reflexive, symmetric, trans 2. Now can you help me one small line? Can you help me one small and interesting line? Interesting line. Careful, interesting line. Everyone listen, interesting line. If I take 1, which is the odd number, if I take 1, which is the odd number, so it should also be odd. If I take 2, which is the even number, it should also be even. If I take 5, odd number, it should also be odd. If I take 6, even number, it should also be even number. It should be even number. Fine, are you getting? It should be even number. So here only 2 equivalence classes are there. Only 2 equivalence classes. What are those? Right? All odd numbers are one group. All odd numbers are one group. All even numbers are one group. Only 2 groups are there. So 2 equivalence classes. You know very well how to write the equivalence classes. In the class notes it is available. Please take care. In the class notes it is already available. Please utilize it. I don't want to teach how to find out equivalence classes. In your notes already there. In your notes already there. Like that you follow. All even numbers one class. All odd numbers one class. All even numbers one class. All odd numbers one class. In your notes already there. Please go through it one time. So R is an equivalence relation having 2 equivalence classes. C is the answer. Right? C is the answer. Right, perfect. Question number 36, answer is C. Question number 36, answer is C. Go to the question number 37. It is also a nice problem. Can you try this? It is also a nice problem. Can you try this? Yeah, 37, what is the answer? Yeah, so I will do this. Now see. So this graph contain 2 power n vertices. This graph contain 2 power n vertices, but every vertex is subsets of n. Every vertex name is subsets of n. Suppose assume n is equal to, suppose assume n is equal to 1, 2, 3. Suppose n is equal to 1, 2, 3. Suppose n is equal to 1, 2, 3. Now 2 power n, 2 power 3. So 8 vertices are there. N is equal to 1, 2, 3. Right? So if you see all the subsets 2 power 3, 8 vertices are there. One vertex name is pi. One more vertex number is 1. All subsets. One more vertex number is 2. One more vertex number is 3. One more vertex number is 1, 2. So 2 power n vertices of a graph G correspond to all subsets of size n. All subsets of size n. Right? 1, 2. Next one. 1, 3. 2, 3. Next one. 1, 2, 3. So like this. 2 power n vertices of a graph G correspond to all subsets of a set of size n. Right? Okay, fine. These are the vertices names. These are the vertices names. Okay, fine. That is okay. That is okay. What he is saying? 2 vertices of G are adjacent if and only if the corresponding sets intersect in exactly 2 positions. Can you help me? Can you help me one small thing? Can you help me one small thing? If I do intersection of these two, let me ask you, if I do intersection of these two, will they meet? Intersection is 2 people? Yes, they are adjacent. If I do intersection of 1, 2, 3 and 2, 3, 2, 3 is the exactly 2 positions. They should meet. Yes, true. Yes, true. If I do intersection of these two, that will also. If I do intersection of these two, this is also. Exactly 2. But one thing is true. If you do intersection of this person and anyone, cannot be 2 people. This person intersection anyone cannot be 2 people because he is having only 1. If you do the intersection of this person anyone, you don't get 2. Intersection of this one anyone, you don't get 2. So n is equal to 3 given. 4 people are having degree 0. He is asking the number of vertices of degree 0 in G is, I think, 3 given 4, n given n plus 1. So most of the things you no need to do any proof. Please substitute. One person intersection any cannot be 2. One person intersection any cannot be 2. 0 people intersection any cannot be 2. So all 1 length people, 0 length person is the answer. All 1 length subsets, 1 length subsets are n. Next one, 0 length subsets, 1, total n plus 1. 1 length subsets are n, 0 length subsets are 1, total n plus 1. Someone is saying n is given, of course, set size is 6 length. Can you help me now? 6 length, listen everyone now. Set contain 6 means subsets contain 1 length also. See, set size is 6 people. Set size is 6 people. All subsets if you take, 0 length also there, 1 length also there, 2 length also there, 3 length also. Any size of set, you have 1 length subsets also, you have 0 length subsets also, you have 2 length subsets also, everything. If I take n value 6 or more than 6, if I take n value 6 or more than 6, right, n value 6 if I take, right, 2 power 6 vertices are available. N value 6 if I take, 2 power 6 vertices are there, where those 2 power 6 are subsets of these 6 people. Subsets of 6 people, 1 length also. Subsets of 6 people, 2 length also. Subsets of 6 people, 0 length also. Yeah, you got. Yeah, you got. Go to the next one. Question number 38. Question number 38. Complete this also. R1 saying that A and B related if and only if A plus B is even. Yes, we done already. A plus B is even. Next one, A comma B related if and only if A plus B is odd. Next one, A comma B if and only if A into B is greater than 0. A comma B is related if and only if A minus B is less than or equal to 2. So, what is the answer you are thinking? Yeah, let me try once. Listen, let me try once. Two people are related if their sum is even. Can you help me? Two people are related if their sum is even. Can you help me? Can you help, 2, 4. Their sum is 6, even. And one more. 3, 3. 3, 3. This can be written 2 into 3, even. Next one, 4, 4. This can be written 2 into 4, even. So can you help me one small line now? Is it reflexive? Is it reflexive? Yes. Is it symmetric? Symmetric. 2, 4 means 4, 2 also. Symmetric also. Is it transitive? 2, 4, even. 4, 8, even. 2, 8, even. Transitive also, please check. So no doubt at all, R1 is equivalence relation. R1 confirm. R1 confirm. Let's see R2. Listen, see the answer. Very interesting. Very interesting. R2 fail. Why? R2 fail. Why? Why is A plus B is odd is saying. A plus B is odd. Can I help you now? 2 plus 2 even. 4 plus 4 even. So remember, reflexive property gone. Reflexive property gone. Odd no chance. Same people if you take, odd gone. Same person if you take, it is gone. So first one is not satisfying. Sorry, second one is not satisfying. Reflexive. Whenever reflexive gone, where is the chance of equivalence relation? So, right, R2 is gone. R2 equivalence relation gone. R2 equivalence relation gone. Right? Let's go to next. Can you help me? Interesting one. Can you see this? Interesting one. Can you see this one? 2 into 4 greater than 0. Then 4 into 2 also greater than 0. So symmetric. Next one. 2 into 2 greater than 0. So reflexive. Next one. 2 into 4 greater than 0. 4 into 8 greater than 0. Then 2 into 8 also greater than 0. Transitive also satisfied. So I think 3 also correct. 2 into 4 greater than 0. 4 into 8 also greater than 0. Then 2 into 8 also greater than 0. Now I think R3 also fine. Can you see the R4? See the R4. 2 minus 4 less than or equal to 2. 4 minus 6 less than or equal to 2. But 2 minus 6 less than or equal to 2 failed. So transitive failed. 2 minus 4 less than or equal to 2. 4 minus 6 less than or equal to 2. 2 minus 6 less than or equal to 2 is fail. So transitive fail. So I think last one also fail. We have already formula in the class. In the class notes already there, right? Rohit, in the class notes already there, right? The binary relation S is equal to pi. And set. So can you help me now? Pi means it cannot be, right? Neither reflexive nor symmetric. No, symmetric. Symmetric and reflexive? No, not reflexive. Neither reflexive nor symmetric? No, symmetric. So transitive and reflexive? Not reflexive. Transitive and symmetric? Everyone knows. So 40 is D, everyone said. Right, you see the notes one time. Rohit, see the notes one time. We did the class notes. Right? Class also you can see, na? You can see recording also. Yeah, can you do 41 also? It's a nice problem. Please take care of this also. Yeah, you will see the notes. You will see the class notes one time. See the class notes. Recording also possible. Please go there. That place you can see once. Let R1 be a relation from A is equal to 1, 2, 3 and so on 7. B is equal to 2, 4, 6, 8. And R2 be another relation from B to C is equal to 1, 2, 3, 4 and defined below. Some things are given. R1 from A to B, R2 from B to C. An element X in A is related to an element B if their sum is divisible by 3. Yeah, can you help me? What is R1 here? What is R1 here? R1 is from A to B. Sum is divisible by 3. So can you start with 1? 1, 2 divisible by 3? Yes. Next one, 1, 4 divisible by 3? No. 1, 2 divisible by 3? Yes. 1, 4 divisible by 3? No. 1, 6 divisible by 3? No. 1, 8 divisible by 3? Yes. So 1 you done already. Go to the 3. 3, 2 divisible by 3? No. 3, 4 divisible by 3? No. 3, 6? Yes. 3, 8? 3, 8, 11? No. Go to the 5. 5, 2? No. 5, 4? Yes. 5, 4, 9. Divisible by 3. 5, 6, 11? No. 5, 8? 13? No. 5 also over. Go to the next one. 7. 7, 2, 9. 7, 4? No. 7, 6, 13? No. 7, 8, 15? Yes. Please help me. Is it R1? Is it R1? Yeah, can you go to R2? Can you go to R2? What is R2? Can you go to R2? R1 done. Can you go to R2? R2 is a relation from B to C. R2 is a relation from B to C. R2 is a relation from B to C where B is 2, 4, 6, 8. C is 1, 2, 3, 4. Right? And one more thing is saying X plus Y is even but not divisible by 3. Even but not divisible by 3. Even but not divisible by 3. Right? Let's start. 1, 2 even no. 1, 4 even no. 1, 6 even no. 1, 8 even no. So 1 nothing. Go to the 3. 3, 2 even no. 3, 4 even no. So see the second statement. Even but not divisible by 3. 3, 2 no. 3, 4 no. 3, 6 no. 3, 8 no. Go to the 5. 5, 2 7 no. 5, 4 9 no. 5, 6 11 no. 5, 8 13 no. But not divisible by 3. Can you help me? What is the R2? R2. So remember R2. So you have to check BC. I am checking AC. That is the reason. AB. That is the reason I am getting the pi. BC you have to check. Try the BC. 2, 1. I want even. B and C. B and C. 2, 1. 2, 1. No. 2, 2. Even but not divisible by 3. Yeah. Perfect. 2, 2. Next. Next. 2, 3. Even no. 2, 4 even divisible by 3. Yes, leave it. Next one 4, 1 no. 4, 2 6 divisible by 3. Yes, leave it. 6 means no, right? 4, 2 divisible by 3. Yeah, sorry for that. Next one 4, 3 no. 4, 4 8 even number divisible by 3. No. 4, 4 6, 2 6, 4. Check properly. 8, 2. So, if you see the 8, 2, 10 divisible by 3, no. 6, 4, 10 divisible by 3, no. 6, 2, 8 divisible by 3, no. 4, 4, 8, no. If anything missing, check. Someone is saying 4, 1. 4, 1 is, if you see the 4, 1, it is odd. What is saying? X plus y is even, but not divisible by 3. 4, 1 I cannot write because odd. 4, 3 I cannot write because odd. 4, 4, 8. Even. Divisible by 3? No. So, that is the reason I written 4, 4. Someone saying 6, 1. It is odd. I cannot write. 6, 2 I can write because even. Divisible by 3? No. 6, 4, 10 divisible by 3? No. It should be even first. If you are okay with R1, R2, listen. R1 from A to B. R1 is from A to B. R2 from B to C. R1 from A to B, R2 from B to C. But if you see the problem, listen, if you see the problem, R1 from A to B, R2 from B to C, you want R1, R2 from A to C. R1, R2 from A to C. You want A to C. Always you remember, if you want A to C, listen, if you want A to C, R1, R2, R1 from A to B, R2 from B to C. So you should do like this one. Listen, you should do like this one. R2, R1, because you want starting with A. See this one, A to C. You see the class notes properly, A to C. First you want A. Who will give A? This person. He will give A to C. The final thing, he will give A to B. He will give A to B. R1 is completed, you have B. With that B, R2. With that B, R2. So this will goes to A to B, this will goes to, at the end of this one you got B, B to C. Finally A to C will come. Finally this is A to C. Be careful. In the problem is mentioned A to C. Listen, this is the trick here. A to C. He blamed you. He blamed you here. From A to C. From A to C. Oh, starting point A. Starting point A means A to B means R1 should first. Afterwards B to C. A to B, B to C, which will goes to A to C. This is the art. Finally A to C will come. Right? Now start doing. First R1. First R1 is A to B. Everyone listen how to do this one. A to B. Go to the R1. Everyone observe one time. If anything new, please learn. That R1, 1 to 2. So it is 2. In the R2, where is the 2? 2 cancel. 2 cancel. So 1, 2. In the R1, 1, 2. Right? Take this 2, come here. 2 cancel. So 1, 2 came. In the similar way, 1, 2. Starting with 2, anyone? No. So leave it. Next one, 1, 8. Starting with 8, anyone? 1, 8, 8, 2. So 1, 2 already there. So 8 also completed. Leave it. Next one, 3, 6. Starting with 6. So 3, 2. Next one more also there. 6, 4. 3, 6, 6, 4. So 3, 4. 3, 6, 6, 4. 3, 4. Next one. 5, 4. So see this one. In the R1, 1, 2. In the R1, 1, 2. In the R1, 1, 2. In the R2, anyone starting with 2, 2. So 2 cancel. So 1, 2 overall. Okay. Next one. In the R1, 1, 2. R2, anyone starting with 2 other than 2? No one. So 1, 2 completed. Now go to the 1, 8. R1, 1, 8. So in the R2 starting with the 8, anyone? Yes, 8, 2. So 8 cancel. So 1, 2. 1, 2 already there. So like that, 3, 6 also try. 3, 6. In R1, 3, 6. R2 starting with 6, anyone? Yes, 6, 2. So 6, 6 cancel, so 3, 2. Next one, in the R1, 3, 6 there. R2 starting with 6, one more person, 6, 4. 6, 4. 6, 6 cancel. Every possibility how to cover, 3, 4. 3, 4 covered. Next one, in the R1, 5, 4. In the R2 starting with 4, anyone? 4, 4. 4, 4. 4, 4 cancel, so 5, 4. On again. Right, now I think it's fine. So finally, so like that you have to compare one by one. When you are comparing, finally you got this one. So A to C is 122, 322, 324, 524, 722. Please verify properly. Lack of space I adjusted somehow. Please compare properly. So finally A to C becomes, right, option C. Please check properly if anyone is not getting.